Okay. I said we were going to come back and talk about chemistry, but actually first we're going to talk about physics even. But no math, so it's no big deal. Okay, so when we talk about life or anything, when we talk about matter, matter is anything that takes up space and has mass. That means it's something. So any matter is made up of atoms. And so an atom is the basic building block, if you want to call it that. All matter is made up of an atom. Now, atoms are made up of subatomic particles. So subatom particles, smaller than an atom particles. So it ends up, when we talk about atoms, we can talk about the pieces and parts of the atom. And so I'm sure everyone has seen, when you see radioactive kind of stuff, you see that ball and then the stuff flying around it, and you say, oh, that's radioactive. That is kind of a picture of an atom. And so so you had that inner ball, and that's has two different kinds of particles making it up. And then the stuff that's out there flying around, that's another kind of particle. So when we talk about matter, we say, well, all matter is made up of atoms, and all atoms are made up of subatomic particles. And then these subatomic particles are actually made up of other particles. We don't go there, though. The good news is we don't go there. We are only going to talk about the three main subatomic particles of the atom. In the nucleus, that little ball in the center, we have protons and neutrons. And they're big. So you get that ball. So you think of that thing. And then they have like these little tracings of something that's zipping around on the outside, right? Those are electrons. They're little teeny tiny subatomic particles. It ends up those little teeny tiny subatomic particles are 1/2000th the size of the other two, the protons and neutrons that are in the nucleus. So an atom consists of a nucleus with protons and neutrons in it, and electrons that have energy that are zipping around outside. They do have mass, but they're very, very small, and they carry energy. Okay, so before we get into more of that fun, let's talk about properties of matter. So we had said matter is composed of atoms, and we know even the little component parts of an atom. And we had said that what forms does matter exist in? So you say, well, let's see, what do I have around me? Everything is made of matter. So anything, what did we say matter is? Anything that takes up space and has mass. I take up space, I have mass. You take up space, you have mass. These books back here, all of that. I could go on and on and on. This is all matter. They're all made of matter. But what are the states of matter? I'm solid, right? So one of the states of matter is a solid. So what else is there? There's liquid. Yeah. So solids, liquids, we had said up there, gas, right? So solid, liquid, gas. There's another one that we don't even talk about, it's plasma. It's, I don't even know how to describe it. So anyway, we're going to just talk about the three main forms of matter being solid, liquid, gas. So it ends up that we have a law. It's the first law of thermodynamics in physics. That sounds really technical, but it basically says that under normal circumstances, and so, not in a nuclear reactor or something like that, but under normal circumstances, matter is neither created nor destroyed. It just changes form. So I said, I eat food, I use it to produce energy, and I exhale CO2. So it went from a solid to a gas. So this is an example of the conservation of the first law of thermodynamics, which states that matter is neither created nor destroyed. Okay, so we don't go too deep into that in this class. Other classes, we keep delving deeper into that, but for this class, we kind of skim along the surface of science. We don't get too fussy about it all. All right, so we're going to flip the page, and I think we are on slide 13, if I'm counting correctly. Yeah, it says 2-13. Okay, so elements have predictable characteristics. So, what is an element? All of those different kinds of atoms, depending on how many subatomic particles there are, protons in particular, specifically protons, it determines what you are. Any atom, if I told you the number of protons, you could go to a chemistry book and look at something called the periodic table, and you'd say, 1 proton? Why, that's hydrogen. It's simple. It says it right there. And then if you had 2 protons, you'd say, why, that would be helium, 3 lithium, and so on and so on. So the identity of an atom is really determined by the number of protons that are present there. Now, the number of protons that are present there determines the number of electrons that are buzzing around outside. And depending on the number of those, elements act differently. And this is always hard for me to teach because I'm trying not to go too deep, but then you don't understand what the heck I'm talking about. So we have all these different elements that are identified by the number of protons that are present there, such as, and your slide says, such as phosphorus or nitrogen. Why were we talking about that? Because of the pollution, right? So anyway, so elements are substances that can't be broken down any further. You can actually break them down, but they don't function in a normal manner. So if you break them apart, they are no longer functioning as hydrogen, helium, lithium, phosphorus, or nitrogen. So we have 115 known elements, and they behave differently. And I made reference to that just a minute ago when I said the number of protons determines how many electrons are buzzing around outside. And it ends up, they either hang around and the element is very stable, or you can lose an electron. So anyway, so they have different characteristics. Sometimes they're highly reactive. Sometimes they wouldn't react if their life depended on it. They're stable. So in you and I, what are we made of? That's kind of interesting. What are you and I made of? Well, 96%. So most of what is me or you, any living thing, is going to be oxygen, carbon, hydrogen, and nitrogen. Those are the main atoms in you and I. And so when we talk about life, we'll be talking about organic chemistry. And we don't talk much about it, but a little bit. And what is organic chemistry? It's the chemistry of carbon. We are mostly carbon. Yeah. Okay. So it ends up, depending on how many electrons you have flying around in each of these atoms, and we said that's determined by the number of protons, it ends up that sometimes they're very comfortable there. So here's the deal. We have what we call energy shells or electron orbits. And if an atom has a full number of electrons in its outermost orbit, and that's determined by the number of protons, then it hangs on to them. It says, I have 8. Most of the electron orbits are filled with 8. So if there are 8 of them there, nothing happens. Now, what if there's 1? Now, one thing I haven't mentioned about these subatomic particles is that the protons that are the big ones that are in the nucleus, they're positive. They have a positive charge. The electrons that are tiny and are flying around in these orbits that I just brought up, they are negative. Now, if you take a battery, or not a battery, if you take 2 magnets, and at one end you have a negative charge, at the other end you have a positive charge, and then you have another one. We said negative is here. If you have positive here, they go click. They stick together. But if you reverse it, oh boy, where you have negative to negative, you can't quite push them together, right? So anyway, my point is, positives and negatives attract. So we have electrons that are negatively charged that are attracted to those protons, but they don't go into the nucleus because they have energy. So they have so much energy, they orbit, they buzz around and around and around. But we said atoms want to have the full number of electrons in that outermost shell. So if you've only got 1 out there, what do? Well, you can give it to somebody that has 7. So an atom that only has 1 outermost electron can give it to another atom that has 7 outermost electrons. Now, one other point that I mentioned, but I want to stress it again here, is that you have the same number of protons as electrons unless you gave one away or unless you got one, right? So if you have 6 electrons and 6 well, let's not say that. We'll say if you have 7 protons and 7 electrons, and you receive one negative, an electron is negative, then you would have 7 protons and 8 electrons. That makes you negative, right? So if you have 7 and 7, it's equal. But 7 and 8 negatives, that makes you a negative. And the atom that gave one of those negatives away now has an extra positive proton, right? So it's positive. And so what we can do is this is what we call producing what is called an ion. An ion is an atom that has a charge, and they basically get a charge either by giving away an electron, and that means they're positive, or they received an electron, and that makes them negative. So we have positive and negative ions because of movements of these electrons. All right, I'm going to stop right here, and I'm trying to decide if I want to stop right here for sure. I think we'll probably just stop right here today. How's that sound? Good enough? And we'll pick up some more of this heavy-duty stuff next time. All right, see you guys later.